Okay, we're looking at seasonal indices and how to calculate and use seasonal indices. These can be based on some examples from the book. So first we're going to show you how to calculate the seasonal index. And the first thing you've got to do is take the average. So we just got 1 year's of data. So we're just going to take the average of all of those. So the average is going to be the total divided by how many you have. So it's divided by n, so that's 162 if you add up all those numbers, and you've got 12 months, so you get an average of 13.5. So now we're going to take every single one of these months and divide by 13.5. Let me just clear things up and I'll show you that. So as you can see, every single value now has to be divided by that average of 13.5. And so we can get some values, and I can quickly put these up here. So just 2 decimal places is all I'm doing here: 0.89, 0.96, 1.04, and so on and so on. So as you can see, we've got all our seasonal indices now. So this is the seasonal index for each of those individual months. And if you add them all up, you should get what number? Well, you should get 12. And if you do add up all of these numbers, I'll just highlight that. So we're saying all of these numbers, all of them, if you add them up, the sum will equal 12. Why? Because you've got 12 months. So if you did 4 quarters or 4 seasons, the sum would be 4. Now I just want to point out a few features of these. So remember, the average is 13.5. So January here, you can see that the value is 0.89, less than 1, because 12 is less than 13.5. Whereas June over here, June is 15 divided by 13.5, so it is going to be more than 1. So that's what you can see. So like a really, really good season, in this case, this is just the season of December, you get a very high value, and then a really terrible one like this 8 in September gets you a really low value. Yes, that may have been Boris if you can hear him in the background. Now, the point is here, like if I want to then de-seasonalize future values, you've got to use a formula. So we always got to use the basic formula, which is de-seasonalized equals the actual figure divided by the seasonal index. Now, in this example, we don't have just the 1 year. We've simplified it by having just the 4 seasons, but we realized we've got to average this way. I'm going to do that 3 times for each of the years, but then we're going to average down this way and like this. And you can understand what's going to get confusing, and that will give you your final SI. Okay. I just want to show you a graph of the data first, and you can see that we've got these regular troughs here. That's spring, so it's always down there on the 4, and then on the 8, and then on the 12. So it's definitely seasonal data that we should be doing that. But you can see like there's still an increasing trend along those, and then if you look at the highest peaks here, they're also going with an increasing trend here. But what we're trying to figure out is like, okay, so you're going to have some sort of average trend line like this, but do you need to panic when your sales go down here, or can you go, oh, well, that's normal? And do you go, woohoo, when we're up here, and go, actually, it could have been better? And that's the point of seasonal indices. So the first thing we're going to do is we're going to average across each year this way. Okay, so I'll just delete those arrows to make it doesn't look too messy. And so you've got to sum them all up. So if you add up 920 and 1085 and 1241 and 446, you'll find yourself with 3692, and we divide that by 4 because we've done 4 seasons, and we get the value of 923, which means every single one of these values has to be divided by 923. So we have to divide this by 923, divide by 923, divide by 923, divide by 923. And we're going to just repeat that for the next year. So here you go. You can see I've got all the averages and I've placed them in there to show what's happening with the data. And you can definitely see the average as we're going down here is definitely increasing. So every year it is increasing, and we can see that in each of the months as we go down. So first of all, then we've got to get each one of those things, and we're going to just round it off to let's call it 3 decimal places, and put those values in. Okay, so as we can see here, we've got all the values now, the reds and the blues and the greens for the 3 years. And so all we have to do now is average down. So we're going to take these 3 numbers and get an average, and then these 3 numbers to get an average, then these 3 numbers to get an average, and these 3 numbers to get an average. It's fun times, isn't it? And if you do those values and do it to 2 decimal places, you should get those numbers. So you just got to add up those 3 numbers and divide by 3. So now you actually have the seasonal indices. Now it's important to think about what some of this means. So this is actually, so summer values are normally 3% more. Autumns are normally 15% more. And winter is normally 30% more. But this is the tricky question, and they have to throw this in exams, not necessarily on SACs, but this is actually 48% less, and you might be tricked into thinking 52% less, surely, but no. Remember, we're talking the difference between the number 1 and this, so 100%, to get from 100% to 3% more, so it has to be 100 plus 3. But to get from 100, you've got to minus 48 to equal 52, whereas over here it's 100 plus 3 is 103. So that's what you have to be thinking about with those things. There's just a little trick they often throw at you. So what I've done here is that this orange line is actually the deseasonalized data. If I can remember how to spell deseasonalized data. And so once you've got that data, you can actually see that obviously these troughs, you can see that they've actually been brought up, which is what you'd expect because you've got a regular slump, so it's not unusual to have that. And then these peaks have been brought down, which is what you expect. Like you go, well, let's don't get too excited. We always have big sales at that time of the year. But what you can definitely say though is that this is definitely a good spot right there, if I haven't covered it in purple. So deseasonalized data is a form of smoothing, and this is the effect that it has. All right, going quite fancy here now with my Excel, and you can see that this green dotted line is actually the trend line for the deseasonalized data. And that can definitely shows where the strengths and weaknesses are with this data. So again, because you see the green trend line, this is above the trend line good, this is below the trend line bad. And so now you can definitively say, ignoring all the variations from the seasons, when you've had a good time, when you've had a bad time, and you can see we're coming back into the good times because we're going above the trend line there. But that was a bit of a bad slump. Still got a bit of a slump in certain times of the year. I think that was spring. But the big peaks just aren't really there anymore, except for this big one over here. Okay, so let's create that deseasonalized data. So deseasonalized equals the actual divided by the SI. So everything in summer has to be divided by this number, and everything in autumn by this number, winter by 1.3, and spring by 0.52. So this is like 920 divided by 1.03. If you round that to the nearest dollar, you get 893. Divide this by 1.03, you will get 1005, and if you divide this by 1.03, you will get 1261. And you do the same thing over here, but now it's divided by 1.15, and you would get 943, and just so on and so on. And as you can see, now I've done all that working. The wonders of technology. Just have a pause in the video. We can still see like, oh, not that. The highlight button might be better. The 893, it is increasing down, and this 943 is increasing, that 955 is increasing, and that's definitely increasing. So we are seeing that increasing trend that we said definitely existed, but now we've smoothed it out when we did, and you could see that from the graph. So the 659 is much bigger. It's 1267. That was a really awesome spring, even though it's much less than the previous winter value, which was actually brought down to just 1151 because of the seasonal index. You normally expect winter to be good and spring to be terrible. So now we can see that definitely the spring was better than the winter, just looking number to number. 1151, 1267, 1267 is better. It was the better time.